You know what really gets me? People walk around thinking they know what real means. They point at a table and say, that's real. They touch a wall and say, that's solid. But let me tell you something that'll keep you up at night. You've never actually touched anything in your entire life. That table? It's mostly empty space. Your hand? Also empty space. What you call touching is just electromagnetic forces between atoms screaming at each other to stay away. You're floating through life on invisible force fields, and nobody bothered to tell you. And here's the kicker, the colors, you see? They don't exist out there. Red isn't real. Blue isn't real. Your brain is making it all up, like some kind of internal movie projector showing you a film and convincing you it's the real world. I spent 50 years studying physics, and I can tell you with absolute certainty, reality is nothing like what you think it is. Nothing. The universe is playing the most elaborate trick on you, and the punchline? You're made of the same trick. Want to know how deep this rabbit hole goes? Buckle up. Let me start with something simple. You think you're sitting there, right? Solid, real, substantial. But here's what's actually happening, and I mean actually happening, not some philosophical nonsense. Every atom in your body is 99.99999% empty space. If an atom were the size of a football stadium, the nucleus would be a pea at the center, and the electrons would be tiny specks somewhere up in the nosebleed seats. Everything in between? Nothing. Void, emptiness. But Feynman, you say, I can touch things. I'm solid. No, you're not. You've never been solid for 1 second of your life. What you experience as solid is electromagnetic repulsion. When you sit in a chair, you're not actually sitting on it. You're hovering about an angstrom above it, held up by the electromagnetic force. The electrons in your backside and the electrons in the chair are repelling each other with such force that it feels solid to you. It's all forces. No touching, ever. Everything you've ever touched was just forces pushing back at you. You've been living your whole life in a ghost world of force fields, thinking it was solid matter. Now, let's talk about what you see. You look at an apple and you say it's red. Wrong! The apple isn't red. Redness doesn't exist out there in the world. What exists is electromagnetic radiation with a wavelength of about 700 nanometers bouncing off that apple. This radiation hits your eye, triggers some chemical reactions in the rods and cones, sends electrical signals to your brain, and then, and only then, does your brain create the sensation you call red. The apple itself, it's not red. It's not any color. It's just sitting there, vibrating with atoms, reflecting certain wavelengths of light. Color is something your brain invented to help you distinguish between different wavelengths. It's a user interface, not reality. You know what else isn't real? Time. Oh, this one really gets people upset. But listen, in Einstein's equations, there's no preferred direction of time. The laws of physics work just as well going backward as forward. Time doesn't flow. That's an illusion created by entropy and your memory. You think time moves from past to future because you remember the past and not the future. But that's just because entropy increases in one direction. It's not because time itself has a direction. Time is just another dimension, like space. The universe doesn't care about your sense of now. In fact, now doesn't even exist in any absolute sense. If you're here on Earth and I'm on Mars, we can't even agree on what now means. Your now and my now are different depending on how we're moving relative to each other. Einstein figured this out in 1905, and people still don't get it. The universe doesn't have a universal clock saying it's now throughout the cosmos. Every point in space has its own version of now, and they're all slightly different. Time is relative. Your now is not my now. And here's where it gets really wild. Let's talk about particles. You think particles are little balls, right? Little tiny spheres bouncing around? Wrong again. An electron is not a little ball. It's not a wave either. It's something that we don't have words for, because nothing in your everyday experience is like it. We call it a quantum object, and it has properties of both particles and waves, depending on how you look at it. Before you measure an electron, it doesn't have a position. It's not that you don't know its position. It literally doesn't have a position. It exists as a probability cloud, a smear of possibility spread out through space. Only when you measure it does it suddenly collapse into having a definite position. Does that make sense? No, it's absurd, but it's true. I spent years calculating with this stuff, and the predictions match experiments to 10 decimal places. Nature doesn't care if it makes sense to you. And the real kicker? You're made of these quantum particles. Every atom in your body is quantum mechanical. So in some sense, before someone looks at you, you're also a probability cloud. Now, I'm not saying you disappear when nobody's looking at you. That would be stupid. But I am saying that the you think you are, solid and definite, is not what's actually there at the deepest level. What's actually there is so strange, so different from everyday experience, that we had to invent completely new mathematics just to describe it. And even then, we can only predict what will happen. We can't really explain why it happens. Reality isn't real, at least not in the way you think it is. Now let me tell you something even stranger. You ready? The universe might not even exist when you're not looking at it. I know, that sounds like mystical garbage. But hang on, because this comes straight from the experiments, and the experiments don't lie. We did this thing called the double slit experiment. You shoot electrons at a barrier with 2 slits in it. Common sense says each electron goes through one slit or the other, right? Like throwing baseballs through 2 doors, each ball goes through one door. Wrong. When you're not looking, each electron goes through both slits simultaneously. We know this because we get an interference pattern on the detector screen, the kind of pattern you only get when waves overlap and interfere with each other. 1 electron, 2 slits, both at once. Okay, Feynman, you say, let's just watch which slit it goes through. Great idea. So we put a detector at the slits to see which one the electron uses. And you know what happens? The interference pattern disappears. Suddenly the electron acts like a normal particle and goes through just one slit. The act of observation changes reality, not because of consciousness or anything mystical, just because any measurement requires interaction, and interaction changes the system. But still think about what this means. The electron doesn't decide which slit to use until you force it to by measuring. Before that, it's doing something so weird we can't even picture it properly. And here's what really bakes your noodle. This isn't just electrons. Everything is quantum mechanical. You, me, this chair, the moon, everything obeys these same bizarre rules. We only seem classical and definite because we're big and constantly interacting with our environment, which acts like a measurement. But at the fundamental level, reality is probabilistic, indefinite, and contextual. It literally depends on how you look at it. Now let's talk about what things are made of. You think matter is made of particles, and particles are the real stuff, right? Well, I hate to break it to you, but particles aren't the fundamental thing either. What's fundamental are fields, quantum fields that permeate all of space. An electron isn't a little ball, it's a localized vibration in the electron field. A photon isn't a particle of light, it's a ripple in the electromagnetic field. Everything, and I mean everything, is just vibrations in quantum fields. You're not made of stuff, you're made of patterns, vibrations, excitations in fields that fill the universe. It's like, imagine the ocean. A wave in the ocean isn't a thing separate from the ocean. It's just the ocean doing something, vibrating in a particular way. That's what you are. You're the universe vibrating in a pattern complex enough to think it's a separate thing. You're not in the universe. You are the universe, temporarily arranged in a configuration that can look at other parts of itself and ask questions. And here's something that'll really twist your mind. According to quantum field theory, empty space isn't empty. The vacuum is seething with particles popping in and out of existence. Electron-positron pairs appearing from nothing, existing for a fraction of a second, then annihilating back into nothing. Nothing isn't stable. Given enough time, nothing will spontaneously become something. The vacuum has energy. Empty space itself is a thing, not the absence of things. So when you look at what appears to be empty space, it's actually a roiling foam of quantum activity. Particles flickering in and out of existence faster than anything could ever detect them directly. But we know they're there because they have measurable effects. They change the energy levels of atoms in ways we can calculate and observe. Reality is far, far weirder than emptiness. It's more like a crazy quantum dance that never stops, not even for a second, not even in the emptiest regions of space. Now here's where I'm going to tell you something that sounds impossible. The fundamental equations of physics are time reversible, but you never see things unbreak. You never see a broken egg spontaneously reassemble itself. Why not? It's not forbidden by the fundamental laws. An egg unbreaking would be perfectly consistent with quantum mechanics and relativity, but you never see it happen. The answer is probability. There are so many more ways for an egg to be broken than to be whole that the chances of random motion spontaneously reassembling it are effectively zero. Not impossible, just stupendously unlikely. But here's the thing. This means the arrow of time, your sense that time moves forward, is just statistics. It's not a fundamental law. It's just that entropy almost always increases because there are more high entropy states than low entropy states. Time's direction is an accident of probability, not a law of nature. And you know what else? The equations that describe all of this, quantum mechanics, relativity, quantum field theory, they're just maps. They're not reality itself. They're mathematical descriptions that let us predict what will happen. We don't know why the universe follows these equations. We don't know why there's something rather than nothing. We don't know why the laws are what they are instead of something else. I spent my whole career calculating and predicting, and I could tell you what happens with incredible precision. But why? That's still a mystery, and maybe, just maybe, that's the most important thing I learned. Reality isn't what it seems. Our intuitions are wrong. Common sense fails at the quantum level, and the universe is under no obligation to make sense to you. But here's the beautiful part. Even though it doesn't make sense, we can still calculate it. We can still make predictions. We can still understand it mathematically, even if we can't picture it. Reality isn't real in the way you think, but it's still there, still following rules, still comprehensible to mathematics, even when it's incomprehensible to intuition. And that's the universe for you, stranger than you can imagine, but not stranger than you can calculate.